Hi, and we're going to be taking a look at relations in functions in this video. Class, say hello.
Hello.
Hello. So here, we're going to be discussing the idea of x and y intercepts of relations. So the x-intercept of a relation is where the relation intersects the x-axis, and the y-intercept of a relation is where the relation intersects the y-axis. Okay, so I got an example here. Now is this a function, first of all? Is this a function or just a relation? Okay, it's a function. It passes our vertical line test. Is this continuous or discrete?
Continuous.
Continuous. So now, where does this cross the x-axis? At -3. So we'd say that it's x-intercept. So, where's my little pen here? This is at -3. Okay, where does it cross the y-axis? Yeah. So it has an x-intercept, or an x-intersection of -3, and it has a y-intercept of 5. So on a graph, it's really easy to see where it intersects the y-axis and x-axis. We just have to see where it crosses the axes. So in this case here, this equation, y is equal to 5/3x plus 5, is exactly this function here. So what we're going to take a look at next is, what if I didn't have this graph? What if I only had the equation? How could I figure out what the x and y intercepts are? So let's take a look at that. So with the equation alone, what we're going to use is our old friend, table of values. Hi, table of values. So here we've got a linear function. We got 3y is equal to 5x plus 15. So the trick is as follows, is that when x equals 0, the value of y is the y-intercept. And when y equals 0, the value of x is the x-intercept. So let's go back here and see that this makes sense. So I'm on the x-axis when my y value is 0. So when my y value is 0, I'm restrained to only being on the x-axis. And when my x value is restricted to 0, I'm restricted to being on only the y-axis. Okay, so it seems a little bit counterintuitive when we first say it, because people like to think, okay, if x is 0, it should be the x-intercept. But if x is 0, you get your y-intercept, because y is the value that's free to be chosen. When y is 0, the x value is your x-intercept, because x is the value, which is free to be chosen. So let's take a look at solving this guy. We're going to use a super powerful but subtle device called let. Okay, so let is a super important word in mathematics, and we're going to use it in the following way. We're going to start out by saying let x equals 0. Okay, now it seems silly to have to put let, but let statements are kind of a foundation, so make sure that we put them. So if I let x be 0, I'm going to rewrite this function, but wherever I see an x, I'm going to replace it with 0. So this is our substitution. So I'm going to rewrite this as 3y is equal to 5 times 0 plus 15. Okay? So what we're going to do now is we're going to simplify this, and we're going to solve this equation. So notice that the left-hand side is going to remain just 3y, because there's nothing to simplify there. So what's 5 times 0? 0. What's 0 plus 15? 15. Okay, so now 3y is equal to 15. What do I have to do to both sides to find out how much 1y is? Yeah, so I'm going to divide both sides by 3. And this gives me y is equal to, what's 15 divided by 3? 5. So this gives me a y-intercept of 5. Okay? So now let's do the same thing, but with letting y equal 0. I'm going to draw a little line here. So we're going to let y equal 0. So letting y equal 0, and see if you can beat me at this, we're going to have 3 times 0 is equal to 5x plus 15. So now all we have to do is simplify. Well, what's 3 times 0? 0. So we get 0 is equal to 5x plus 15. Okay. Can anybody see what the answer is just by your math skills, by your multiplication skills? So I have to add something to 15 to get 0. Close, close. So we're going to use some of our algebra power here. Okay. Oh, I heard it. Yeah, it's going to be -3. So let's show how we get this if people are having trouble seeing. So we're going to use our solving techniques from Math 9. So the first thing we need to do is we're going to take away any constants we have. So what's the opposite of positive 15? So I have to subtract 15 from both sides. Right? -15 on both sides. So this is going to leave me with -15 is equal to 5x. So what do I do now to get the x by itself? Divide both sides by 5. You got it. Okay? So what we're going to get, finally, is what's -15 divided by 5? -3 is x. And we'll go back up here. And we've got -3. Now, hold on a second. Didn't we just say that that was the exact same x and y intercept for our previous function? Right? So we had 0, 5, -3, 0. So if we go back here, those were the exact same values. So as it turns out, the function y is equal to 5/3x plus 5 is in fact the exact same function as 3y is equal to 5x plus 15. So these two functions are exactly the same. They're all that's happened is we've changed it using algebraic manipulation. Okay? So when you watch this video again over the weekend, I want you to, and I'll have a chocolatey treat for those who can explain why these two functions are indeed equal to one another. Yeah, I'll have some delicious... Which one? Sorry?
Algebraic.
Yeah, if you can show me how they're equal. So if you can show me how they're equal, I'll have some chocolate waiting for you. Pardon? Well, we're recording live right now. Hi, Internet. So yeah, you can just go back and watch. No, the answer is no. Moving on. Okay, so it's for Monday, and more than one person can get the chocolate. More than one. It's not like a first come, first served. I know you want it now. You got to wait. Okay, so here we go. We got algebraic manipulation of linear equations review. So, linear equations have two useful forms when it comes to graphing. There's standard form, and this has a few different ways of writing it. So it's y equals the slope times x plus the y-intercept. So I'll put this in kind of one color just so it's easy to see. Okay. Another way to write this is y equals mx plus b. This is our formula, where m is equal to slope, b equals y-intercept. Really, the green and the yellow are the same. All we do is instead of writing slope, we write m. Instead of writing y-intercept, we write b. And this one, the pink one, is really the only different one because this has to do with a table of values. Remember we said that slope is the same as common difference. And in this case here, this is something that you'll see in grade 9, is that the 0th term of a table of values is the same as the y-intercept. Okay, so the connection here to see is that slope is the exact same as common difference, and the 0th term of a table of values is the exact same as your y-intercept. And by 0th term, what I mean is when your input is 0. So for instance here, we consider this to be the 0th term. When x is 0, y was 5, and that's the y-intercept. So let's go a little bit forward here. So these are all considered standard form. They're just different ways of talking about the same type, basically when y is isolated. The next is general form when you have both variables on the same side of the equation. So we say cx plus dy is equal to e, where c, d, and e are any real numbers. So for instance, we're looking at general form and standard form. Well, the last two equations that we just dealt with, one's in standard form, but the other one is not in general form. So let's see the distinction here. So going back. So this is not in general or standard form because both variables are not on the same side of the equation, nor is y completely isolated. Okay, it has a coefficient of 3. However, this one is in standard form because y is completely isolated. Okay, so you just want to kind of refresh yourself, standard form, general form, and these are the kind of things that we first introduced back in grade 9. So now what we're going to do is we're going to take a look at slope. So slope is defined as the change in y and change in x for a linear function. Okay? So in this case, change in y divided by change in x gives you the slope of a linear function. So we can also think of this as, because y is the same as the dependent variable and x is the same as the independent variable, this is the same as change in the dependent variable divided by change in the independent variable. And finally, stealing from science, the Greek letter delta means the exact same thing as change in most cases when we're going to be using it. So when we use the Greek letter delta in grade 10, we mean it to have the value of change. Okay, it's just short form for change. So change in y divided by change in x. And remembering from grade 9 that slope is the exact same thing as the common difference. Okay, slope and common difference are synonyms of the exact same concept. So what we want to do is we want to find the slope and common difference from both a table of values and a graph. So this is going to be similar to what we did yesterday. So if you're told that a table of values represents a function, we really only need to do a comparison for 2 of these. And if it's a linear function, sorry. So what's the difference between 4 and 7? 3. What's the difference between 7 and 13? 6. So what's the change in y? What's the change in y? Well, no, go slower, go slower. The slope is 2. What's the change in y? 6. Okay, the change in y is 6. What's the change in x? And what's 6 divided by 3? There we go. Okay, so for a table of values of a linear relation, all you have to do is take the change in y over change in x. And the neat thing is it doesn't matter which pairing you use. Like I could go from this guy, I could go from this guy here to this guy here, and this guy here to this guy here. It's still going to work. So the jump from 4 to 11, what's that? From 4 to 11?
Oh, no.
It's 7. Okay, from 7 to 21. 14, thank you kindly. Okay, so we're going to do the same thing here. What's the change in y? 14. What's the change in x? 7. What's 14 divided by 7? 2. Okay, so it doesn't matter if you have a linear relation, linear function, it doesn't matter which pairing you have. It's just change in y divided by change in x. So for this next one, we're going to use a term you might not have heard in a while. These are called integral points. Okay, raise your hand if you remember integral points. Have you ever heard integral points? Okay, one person remembers integral points. Okay, so I want you to take a look at this graph. So where you see the vertical and horizontal lines crossing, those are integral points because they cross at integer values. So where these lines cross, it's like, you know, a whole number, comma, some other whole number, okay? Or some positive number, comma, some negative number, right? So anytime you're dealing with whole numbers, whether they're positive or negative, we call those integral points. So the idea here is all you have to do is find 2 different integral points on your graph. So I've got one where the huge, gigantic red dot is, and I've got another one right here. Okay? So what we want to do is we want to see what's the change in y divided by what's the change in x. So I'm going to use some green here to help us out. Okay, so starting at this dot here, the lower dot, how many do I have to go up to be at the same height?
3.
Yeah, I have to go up 3. How many do I have to go to the right? 2. So the thing to remember is on the y-axis, up is positive, down is negative. And on the x-axis, right is positive, left is negative. So to do this, I start here. I go up 3 and to the right 2. So what's my slope going to be? So my change in y was how much? How much did I have to go up? 3. Divided by how much did I have to change my x? And they were both positive values, so the slope is 3 over 2, or 1.5, exactly. So you could say 3 over 2, you could say 1.5. If you want to put it into a mixed fraction, you can say 1.5. All of these are perfectly acceptable answers. Okay. So any questions so far with slope? Is this kind of, are you guys remembering slope? Is it starting to percolate? Be like, rise and run. This is something that you guys have seen before? Okay. That's right, that's right. Good old rise over run. Love rise over run. Okay, let's take a look at some difficult examples here. Okay, so we're going to use the exact same technique, even though they look more challenging. So, first step, when you're dealing with a graph, find some integral points. So I've got an integral point here. I've got an integral point here. Okay, so have to remember that traveling up is positive, down is negative, left is negative, right is positive. So let's say I'm starting here. So do I have to go down or up to meet this guy?
Down.
Down by how many?
2.
2. Okay, so to start out, my slope is going to start with a negative 2. And it's going to be over something. Yeah, and then here, 1, 2, 3. So it's over positive 3. And that's just negative 2/3. So the slope of this equation would be negative 2/3. What would the common difference be? What's the common difference of this guy? Negative 2/3, because remember, slope and common difference are the same. So that's a classic question to ask on a test, wink, wink, nudge, nudge, is to ask you to find the slope, and then as a follow-up question, oh, by the way, what's the common difference? And you'd be surprised by how many people that trips up. So you have to know your vocabulary, okay? Know what we're talking about. So let's try this way. So here, we've got some values, and we're told, remember, that these are linear functions. So all we've got to do is we've got to test between one pair of points, but it doesn't matter which pair. So I'm going to just do the easier one, so these guys. Okay, what's the change in my dependent variable?
3.
No, that's my independent variable, 21. Okay, remember, your dependent variable is the second guy. It's your y values. Okay, my independent variable, what's the change? 3. So what is the slope?
7.
Yeah, it's 21 over 3, which equals 7. What's the common difference?
7.
There you go. Beautiful, beautiful. So the nice thing about common difference, too, is that if you need to find another value, so for instance, if I did the following. If I said that, okay, there's another point here, and it's the point 12, I just forgot to write it, and I know that my common difference is 7, how can I quickly find out what value has to go right here if my common difference is 7? So think about this. If I have a change of 1 here, what's the change going to be here? It'll be 7. Okay? So the idea is for slope, if your x input changes by positive 1, then your y value changes by the value of the slope. Okay? And that's the idea between common difference and slope. So what would be my dependent value here? 79. There you go. So if I had another value here, 13, what value would it have? Yeah. Oh, you said it first, 86. 86. Again. So again, you just have to keep the consistent pattern. If I add 1, then I add 7. Okay? So let's take a look at this next guy. Okay. This is the brand new stuff. Okay, this is the brand new stuff, and this is what's called function notation. So in grade 10, we introduce function notation. This replaces the dependent variable y with a new symbol, f bracket x close bracket, pronounced f of x. So f of x shows that the relation is a function with a dependent variable of, oops, sorry, I have to change that. Not dependent, Mr. Willard, but I know. Independent variable, but I caught myself. Horrible person. I'm going to go to jail. This substitution combines the ability to evaluate functions efficiently with our standard form approach. So in general, when the y variable is isolated, that is when we're using standard form notation, we're going to replace y with f of x. So for example, if I have y is equal to mx plus b, we're instead going to write this as f of x is equal to mx plus b. And instead of y is equal to negative 3 over 2x minus 7, I would write f of x is equal to negative 3 over 2x minus 7. Okay, so this is our new dependent variable. So let's take a look at applying this. So how does the f of x work? So the idea is that whatever replaces x in the brackets here replaces x in the function on the other side. So let's see, and this is the thing I showed you yesterday. So f of x. If I have f of a, it becomes negative 3 over 2 times a minus 7. F of face is equal to negative 3 over 2 times face minus 7. And f of 4 would be negative 3 over 2 times 4 minus 7. And if we do this on our calculator, we see we get negative 13. So the nice thing about function notation is that it combines our ability to have input and output clearly defined just like a table of values does. It allows us more flexibility. So for this same function here, I would like you to find what f of 6 is. Okay? And I'll give you a moment here. Okay, so let's write this out. So what we're going to have is this is going to be negative 3 over 2 multiplied by 6 subtract 7. And this is something we can punch into our calculator exactly as we see it. So I'm going to do it longhand form, so without a calculator. So when we're multiplying fractions and whole numbers, we want to make our whole number into a fraction. So I'm going to think of this as 6 over 1. So the rule for multiplying fractions is tops multiply tops, bottoms multiply bottoms. So this is going to be negative 3 times 6 is negative 18. And 2 times 1 is 2. Now take away 7. So now this fraction here can be simplified. So negative 18 over 2 simplifies to negative 9. And negative 9 take away 7 is equal to negative 16. So what we have is the f of 6, the function of 6, in this case, is equal to negative 16. Okay? So this helps us with our evaluating, which we're going to be practicing today in class. Okay. So lastly here, let's get some practice with function notation and finding x and y intercepts. Okay? So before what I was showing was that we used the table of values and we used our let statements. So if we use function notation, we get to leave our let statements behind. If you keep your y value, then you have to use a let statement. So no let statement means you're forced to use f of x notation. If you don't want to use f of x notation, you have to use a let statement. So it's your choice, but you have to be able to do both and to be able to interpret both. So let's take a look here. I'm going to have x be 0. So my first thing, I'm going to do f of 0 is equal to 4 over 3x minus 7. Okay? So what I need to do here is wherever I see an x, we replace it with 0. Okay? So what's this going to be? What's going to be after we simplify? What's f of 0 equal to? That's right, because anything times 0 is 0. So this is really like f of 0 is equal to 0 plus 7, and that's just equal to 7. Okay? And notice that this matches up with what we already said about standard form. And standard form, this is the y-intercept. Okay? Oops, sorry, I missed a negative sign. So we get our negative 7 here. Okay? So your y-intercept is exactly this value. And that's the nice thing about standard form notation. So now, let's show that we can use this also when your y value equals 0. So in this case, it's just 0 is equal to 4 over 3x minus 7. So in this case, we want to use our algebraic manipulation to solve. So what do I have to do to both sides of the equation first? What's our first step here? Okay. So think about this. You have to get rid of your constant values first. How do I get rid of negative 7? Yeah, I add 7 to both sides of the equation. So this is going to give us 7 is equal to 4 over 3 times x. Okay, so think about this. What do I have to multiply 4 over 3 by to change it into 1? Because I'm not interested in 4/3 x. I'm interested in 1x. Yeah, I multiply it by its reciprocal of 3 over 4. So I'm going to multiply by 3 over 4. And I do that on both sides. So remembering that when we're multiplying fractions and whole numbers, we make the whole number into a fraction. So this is going to give me 21 over 4 is equal to x. So we get the fraction 21 over 4. Okay? There's our value. So let's try out this one. What we want to do now is we want to determine what's the value of x when f of x equals negative 15. So we're going to have f of x is equal to negative 15, and this is equal to 4/3 x minus 7. Okay, so this is solving just like we were doing in grade 9. So the first thing you always want to do is get rid of your constants that are on the same side as your variable. So I have to get rid of negative 7. So the first step is the same. We're going to add 7 to both sides. So what's going to be different here is what's negative 15 plus 7? Yeah, or you get negative 8, right? Yeah, negative 8. So you get negative 8 is equal to 4/3 x. What do we multiply both sides of our equation by? Well, by the reciprocal. Remember, to multiply a fraction to get 1, you always just multiply the reciprocal. So I'm going to multiply by 3 over 4. On this side, I'm going to multiply by 3 over 4. And this is going to leave us with negative 24 over 4 is equal to x. And what's negative 24 divided by 4? Numbers? That is correct. It actually is a number, which is negative 6. Okay?
Nice.
So the value of x, when f of x is equal to negative 15, is negative 6. And we can kind of summarize it as this, that the f of negative 6 is equal to 15. So that would be our final answer in this case. Okay, so let's start our homework.